Hello, I am going to establish one result. That result is uh, k is equals to from 1 till n minus 1 and sine k pi by n. This thing is given. So this is actually equals to n upon 2 to the power n minus 1. Okay. So how I will establish this result? So to establish this result, I am going to use one identity nth root of unity, which is for that I am writing this equation x to the power n minus 1 is going to be x minus 1 into x to the power n minus 1 plus x to the power n minus 2 plus dot plus x plus 1. So this is the identity. But we also know x to the power n minus 1 as when we solve this equation, then this is going to be, their roots are going to be 1, omega, omega square, and etc. up to omega to the power n minus 1. So these are n roots to this equation. Okay, so in that scenario, we can also write x to the power n minus 1 as x minus 1 into x minus omega into x minus omega square into, sorry, dot and into x minus omega to the power n minus 1. So this is the roots in factor form. Our equation is in factor form, and in RHS also in factor form, but in different way. X to the power n minus 1 and plus dot plus x plus 1, right? So x minus 1 got cancelled from both the sides, and now we will have x minus omega into x minus omega square dot up to x minus omega to the power n minus 1, and that is equals to 1 plus x square plus dot plus x to the power n minus 1. And now I am going to put both sides x is equals to 1. Okay, am I allowed to do it? Of course, we can do it. So this thing is going to be 1 minus omega into 1 minus omega square dot into 1 minus omega to the power n minus 1. And in RHS, it is going to be 1 plus 1 plus 1 plus dot plus 1. How many times? N times. N times. Now what I will do, I will do one simplification. So what is that simplification? So that simplification is going to be considering 1 minus omega to the power k. This can be written as 1 minus e raised to iota to the power e raised to iota 2 pi k upon n. We should notice that nth root of unity actually it is x is equals to e to the power 2 iota k pi upon n, and where k is going from 0, 1, 2 till n minus 1. Okay, so here, and but we have already dealt with, we have cancelled out here x minus 1 from both sides. So you should notice this thing that k is equals to 0 condition has already done. We are already done with that. So we will ignore it, right? So our k in our situation, which is useful now, is going to be from 1 to till n minus 1, right? So next time it is going, can be written as 1 minus cos 2k pi upon n minus iota sine 2k pi upon n. And then I will 1 minus cos 2a is going to be 2 times sine square a. So sine square k pi upon n. I use that formula. And minus sine 2 theta is going to be 2 times sine theta into cos theta. So I will use that. So 2 iota sine k pi by n into cos k pi by n. Now, in the next step, what I can write for 1 minus omega to the power k, what I can write. So I will change this term, this very first term, into, I will multiply this first term by iota to the power 4. And iota to the power 4 is just a positive quantity, so we can do it, right? So it is going to be sine square k pi upon n, and then we have here minus sign. So we know minus iota can be written as iota to the power 3. So I will use this identity here. So in the next step, it is going to be plus iota to the power 3 2 times sine k pi upon n into cos k pi upon n. Now I will take something common. So now you can figure it out. It is going to be 2 iota to the power 3 sine k pi upon n. So then we will get iota sine k pi upon n and plus cos k pi upon n. So this further can be written as minus 2 iota sine k pi by n and into, if you notice, this quantity further can be written as, this quantity further can be written as e raised to iota k pi by n, e raised to iota k pi by n, right? So now I will use this thing. So what we were dealing with here, where we left out, I will proceed from here. So where I left, so I will proceed from here. I was doing some simplification to use here, then I will proceed from here. So in the next step, The next step, put everything in bracket. Okay. In the next step, what I will write, so you can notice you can put k is equals to 1, k is equals to 2, so you will get every bracket. So you will get 1 minus omega as putting k is equals to 1, so it is going to be minus 2 iota sine pi upon n into e raised to iota pi upon n. This is first term. Notice this is 1 minus omega. Next time I am going to write minus 2 iota sine 2 pi, putting k is equals to 2 here, 2 pi upon n into e raised to iota 2k pi upon n into the third bracket, and notice this is actually 1 minus omega square. In the next bracket I am going to write minus 2 iota sine k pi upon n into e raised to, here k is not, we have put the value of k as 2, so 2 pi by n, here 3 pi by n, and e raised to iota 3 pi by n. And so on, it will go on, right? Until where? It will go till minus 2 iota sine n minus 1 pi by n and into e to the power iota n minus 1 pi upon n till here, right? So now this is a left hand side and right hand side is going to be n. Okay, so we can write here this is equals to n. Okay, so in the next step we can notice it is actually minus 2 to the power n minus 1 into iota to the power n minus 1 into e to the power iota pi by n, and then powers are going to be 1 plus 2 plus 3 plus dot 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 and plus n minus 1. That is the power of e. And then what we will get, that we require sine pi by n into sine 2 pi by n into dot 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 into sine n minus 1 times pi by n, right? And this quantity is equals to n. Okay. So now in the next step, we will have minus 2 to the power n minus 1 into iota to the power n minus 1 into e to the power iota pi by n into sum of first n minus 1 natural number is going to be n minus 1 into n and whole upon 2. N cancelled, right? And this quantity we require, so I am going to call this quantity as p. P is equals to n. because I don't want to write this huge thing multiple times. You can understand it, right? So minus 2 to the power n minus 1 and into iota to the power n minus 1 into, now you can see this is going to be e raised to iota pi by 2 and whole to the power n minus 1. We can write it, right? Actually, what I have done there, if you have e raised to iota pi by 2 times n minus 1, you can write it as e raised to iota pi by 2 and whole to the power n minus 1. This is very simple rule from class 6, 7, right? And into p, that is equals to n. Next time you can see minus 2 to the power n minus 1 into iota to the power n minus 1 into, and e raised to iota pi by 2 is going to be again iota. So iota to the power n minus 1 and into p is equals to n. In the next step, what we can say, in the next step it is going to be minus 2 to the power n minus 1 into iota to the power 2n 2 times n minus 1 and into p is equals to n. Next time it can be written as minus 2 to the power n minus 1 into iota to the power 2 and whole to the power n minus 1 into p is equals to n. Next time it is going to be minus 2 to the power n minus 1 into minus 1 to the power n minus 1 into p is equals to n. In the next step, it is going to be minus 1 to the power n minus 1 into 2 to the power n minus 1 into minus 1 to the power n minus 1 into p is equals to n. Now you can see minus 1 to the power 2n minus 2, which is even number, and into 2 to the power n minus 1 into p is equals to n. In this scenario, minus 1 to the power 2n minus 2 is going to be simply 1 into 2 to the power n minus 1 into p is equals to n. So therefore, p is equals to n to the n upon 2 to the power n minus 1. So we have proven this result. And what is our p? Our p is required thing. Our p is this quantity. This quantity is our p. This quantity, right? You can notice when I have assumed p, where I have assumed p, I have assumed this quantity as p. This quantity. Okay. So I hope this will help you get some concept. Thank you.